What I will be going over in this video today is the accounting for growth and its equation. Now, growth accounting means the relationship between the growth rate of inputs and the resulting growth rate of outputs. Growth accounting is not a hard subject to talk about because it's something we're all used to. It's just figuring out what we need to know and plugging in the stuff we already know to get that thing we're trying to figure out. Now, as we see here, the growth accounting equation is g of y equals g of a plus a times g of k plus 1 minus a times g of l. And why that might look confusing at first, when you break it down, it's actually quite simple. Now, A is the share of GDP, which is also could be considered Y, is distributed to the owners of capital. And then the share of GDP that's distributed to the laborers is obviously 1 minus A, because that'll equal 100%. Now, G of K is the growth rate of capital, and that gets multiplied by the share of GDP that's distributed to the owners of capital. And the growth rate of labor is G of L, and that gets multiplied by the share of GDP distributed to laborers. Now, the last part that you need to know is G of Y, which is what we're trying to figure out, which is what all that equals, which is the growth rate of GDP. Now, let's do an example to show you how simple this is. So suppose that China annually grew by 9.3%, labor by 2%, capital by 10%, and the share of output to capital is 40%. So let's break it down one by one. Suppose that China annually grew by 9.3%. Well, that's our GDP. That's the output of GDP, or the growth rate of GDP, that all of this equals. So we put that at the front. But we have to remember that it's in a percentage. But we don't want it in that. We want it in a decimal. So we have to divide it by 100. So 9.3 divided by 100 is 0.093. Now, it tells us labor grew by 2%. Now, as we know here, growth rate of labor, G of L, is this thing right here, G of L. So we can put that at the end as we have here. So we can do 0.02, because you have to remember we have to divide it to get in a decimal. Capital grew by 10%. And if we go back, capital goes here, which is multiplied by A. So we put that there. And we have to divide by 100, so it would be 0.10%. Now we have to do a little math before we can get everything we need. The share of the output of capital is 40%. If we go back to here, we see the share of GDP distributed to owners of capital equals A. And that's A right here. A is multiplied by G of K. So we have that part. We know we have to put 0.4 times 0.1. But aren't we still missing 1 minus A? Well, we just figured out A. So all we got to do is subtract 1 minus 0.4, and then we'll figure out what we need to multiply to G of L to get everything we need so we can solve for G of A. So 1 minus 0.4 equals 0.6. So what we have right now is 0.093 equals G of A plus 0.4 times 0.1 plus 0.6 times 0.02. Now, from here is just simple algebra. 0.4 times 0.10 equals 0.04. So you should have G of A equals, or G of A times 0.04 plus 0.6 times 0.02, which equals 0.012. So now we have, I'm sorry, you should not have G of A times 0.04. You should have G of A plus 0.04. So you have G of A plus 0.04 plus 0.012 equals 0.093. So you add 0.04 plus 0.012, which equals 0.052. So 0.093 equals G of A plus 0.052. Now, with our algebra, we subtract 0.093 minus 0.052. which will give us G of A. And G of A equals 0.041, which is what we wanted to find out, which is 41% of GDP growth to the technological change.